Hey guys, welcome back. So in this session, we will have a look at this document, which has some very important information about the computers. And this document will be shared with you. So let's have a brief overview about what is there in this document. So if anything needs explanation, I will try to explain, or else you can study this material by yourself. So it has the information about the computers and different areas about the computers. So first of all, you can see computer is an electronics device. Okay. It is not an electric device. It is an electronic device. And what's the purpose of the computer? It is to perform calculations and operations based on instructions provided by a software or hardware program. Okay. So the purpose is in its name only. Computer means to compute something, right? And it's an electronic device. And what are the characteristics of computer? So computers are fast, okay? Computers are accurate. So if you give proper input, the computer will give proper output. So that's the meaning of accuracy. Then we have diligence, okay? So computers are hardworking. You don't have to stop the computers even after working for 24 hours. The more you work on a computer, the faster the computers will be. And versatility. So computers can perform a lot of different types of operations for you. Then storage. So computers can store a large amount of data or instructions in its memory. Okay, so you can store gigabytes, terabytes of data in the computer, and you can retrieve them at any point of time. So you can see history of computers. So computer was intended for making a person capable of performing numerical calculations with the help of a mechanical computing device. And this was the intention why the computers were imagined or anticipated. But computers were not developed immediately. So what computers we have today, these computers took a lot of time to evolve. Okay. So how they evolved and how they appeared for the first time and all you can see here. So they first appeared as abacus. So abacus was the first counting device, which was developed in China, which consisted of a rectangular wooden frame and beads. The wooden frame contains horizontal rods and the beads, which are passed through the rods. The beads of the counters represent digits. The device is used to perform simple addition and subtraction. Okay. So this is how the computers were imagined and appeared first time. Then we have Napier's bones. And then we had Pascaline. Then we had punched card system. Then we had the Charles Babbage's calculating engines. So this was the first time that it became electronic. So the calculating engines were the difference engines to solve algebraic expressions and mathematical tasks accurately. Then some improvements were made to become the first computer. The modified machine is called the analytical engine. He intended to design a machine with a collection of the 4 basic arithmetic functions. Then we have Hollerith machine. Then we had Mark I computer. Then we had first unprogrammable electronic digital computer. Then we had ENIAC, which means electronic numerical integrator and calculator. So the short forms are very important here. You will not be asked everything, but the short forms and long forms are important. So ENIAC means electronic numerical integrator and calculator, which was for the general purpose. Then we had EDVAC. EDVAC means electronic discrete variable automatic computer. Then we had UNIVAC, which is Universal Automatic Computer. So UNIVAC means Universal Automatic Computer. Then we had microprocessor. And here you can see a quick revision table. So father of computer is Charles Babbage. Father of modern computer science is Alan Turing. Then first non-programmable electronic digital computer is Atanasov Berry computer. Then the first general purpose electronic digital computer is ENIAC. Then the first microprocessor is Intel 4004. The first commercially available computer is Universal Automatic Computer, which is UNIVAC. Then we have generation of computers. So the first generation of the computers, which was between 1946 and 1957. So the first generation computers were huge, okay? They were very huge, like the size of a room. And they used vacuum tubes as the electronic components. They occupied a large space and performed computations in milliseconds, okay? So machine languages were used. So these are the important points about the first generation, and the examples were EDSAC, EDVAC, UNIVAC, IBM 701, IBM 650. The second generation computers were between 1959 and 1965. So these were little better than the first generation computers. They replaced vacuum tubes with transistors. They used assembly languages and batch processing operating system. And magnetic tapes were used as storage. So in all aspects, the second generation computers were better than the first generation computers. The examples were IBM 1620, IBM 7094, CDC 1604, CDC 3600. And then came the third generation computers, which were much better than the second generation. So the time was between 1965 to 1971. So they replaced transistors with integrated circuits. They performed computations in nanoseconds. They used high-level languages like Fortran, COBOL, Pascal, Algo, BASIC. And in this generation of the computers, remote processing, time sharing, multi-programming operating systems were used. Then came the fourth generation computers. They used very large scale circuits, integrated circuits. So the ICs were replaced by VLSI. Semiconductor devices as used as the primary memory. Magnetic disks are used as secondary memory. Problem-oriented fourth generation languages were used. Multiprocessing and multi-programming operating systems were used. Then we had fifth generation computers. The fifth generation computers used ultra large scale integrated chips that contain millions of components on a single chip. And they're still in the developmental stage, which is based on the artificial intelligence. These computers can also respond to natural language input. Biochips were used as memory devices, and KPIS, which stands for knowledge-based information processing system architecture, will be used. Examples are robots and supercomputers. Then we have the types of computers based on the operation. So we have based on operation, which consists of analog computers, digital computers, and hybrid computers. Then based on the configuration, we have microcomputers, mini computers, mainframe, and supercomputers. And you can see some facts here. The first supercomputer in the world is Cray CDC 6600, fastest supercomputer in the world, submitted by the USA. First supercomputer of India, Param 8000, fastest supercomputer in India, Pratyush. And based on the utility, we have general purpose computers and special purpose computers. And based on mode of use, we have palm top computers, we have laptop computers, we have PCs, we have workstations, we have client and server. Then we have fundamentals of computers. So at a very high level, a computer system has four basic parts. They are hardware, software, data, and users. So hardware represents physical and tangible components of the computer. So whatever we can touch, they come under the hardware. Software is a set of electronic instructions called programs, and they make the computers to perform the tasks. Then we have data, which is a set of facts, which is stored by the computers and reads in the form of numbers. Then we have users, okay, who use the computers. And we have motherboard, which is a main printed circuit board of a computer that carries the CPU, ROM, RAM, and the BIOS, that is the basic input-output system chip. Then we have the questions. Which of the following refers to the process of starting a computer from a powerless state and setting it up to the normal working condition? Okay, so the answers for all these, you can find them below. And which of the following looks for system files during the boot process? All right. You can see the answers here. For the first question, it was the fifth option, that is all of the above. Then for the second question, which of the following looks for the system files during the boot process? The fifth question. So better I can explain the answers. So the answer for the first question, it is cold boot, cold start, or you can also call it as cold boot. So cold boot is the process of starting a computer from shutdown and settling it to the normal working condition. A cold boot refers to the general process of starting the hardware. Cold boot is also known as hard boot, cold start, or dead start. Then for the second question, which of the following looks for the system files during a boot process? It is the BIOS. It looks for the system files during a boot process. The BIOS is special software that interfaces the major hardware components of your computer with the operating system. And the third question, specialized program designed to allow input or output devices to communicate with the rest of the computer. Okay. So it is the device driver. The fourth question, which of the following types of computers is known as number cruncher? It is supercomputer. So you can see the explanations here. And you can see the basic computer organization and data processing cycle, how the flow goes. So the input unit is used for giving instructions and data by using the input devices. It converts the instructions to the computer acceptable format, and it supplies the converted instructions and data to the computer system for further processing. So this is the task of the input unit. Then we have CPU. The CPU itself consists of that is control unit, ALU, and memory unit. And the primary memory, we have random access memory and the read-only memory. The random access memory holds the data in the processing stage, whereas the read-only memory holds the data in the permanent state. Random access memory is also volatile. It is also fast, whereas the read-only memory is quite slow and it is permanent. It is non-volatile. Then we have different types of secondary memory like hard drive, floppy disk, CD, DVD, CD-ROM, HVD, zip disks, and all. Then we have the output unit. The output unit provides the information from the computer to an external device. It presents a soft or hard copy of the information which can be readable by the users. Then which of the following is the responsibility of a logical unit in CPU? Then which of the following refers to a standard interface? Which of the following is not robot RAM? Which of the following is not a part of primary storage that holds a software program and small amounts of data? The last question, the storage area for the next likely data or instruction to be processed, preventing bottleneck and slowing of the system is known as. Okay, so let's see the answers for these. The first question is, which of the following is the responsibility of a logical unit in CPU? So it is to compare the numbers. Okay. Then the second question, which of the following refers to a standard interface for connecting a motherboard to storage devices? So it is IDE. Then the third one is, the main function of RAM is to store currently active programs and their data. RAM is volatile, which means the computer is switched off, the contents are lost. The contents of RAM can be changed or deleted. All right. The fourth answer, random access memory, is a part of primary storage that holds a software program and small amounts of data for processing. When you start most software programs on your computer, the entire program is brought from the secondary storage to the RAM. So as I told you earlier, whenever you open a file, it comes to the RAM. When you close or save the file, it goes to ROM. And then we have some computer peripheral devices. The peripheral device links to a computer system to enhance the functionality. It is not actually the core part of a computer system. Okay, like we have input devices, output devices, and storage devices. These are the peripheral devices.